Hello AQR students. Today we are beginning a new unit. This is actually Unit 1. We finished Unit 7. Now we're going back to Unit 1. It is a numerical analysis, and specifically today we are going to be looking at how we estimate crowd size. All right, and talking about some different ways to estimate crowd size. Okay, it's a pretty quick lesson. Let's jump into it. Here we go. Okay, so we are looking at student activity sheet 1 for our second unit that we're going to do, which is a unit on numerical analysis. Okay, so here's what I normally do. So I'm just going to read through this. Estimating the number of people in a large crowd, for example, watching a parade or attending marching in a political rally, is quite challenging and often leads to controversies. One method sometimes used is to focus on a small section of the crowd, such as a rectangular area. So number 1 here says make a square measuring 5 feet by 5 feet and have your friends stand inside it as if they are watching a band at a small club. Count the number of your friends that comfortably fit in the rectangle and find the ratio of this number to the rectangle's area. Explain in your own words what this ratio means. All right. Well, in class right now, this year, in this class, in AQR, I have 18 students, and that's, most years I have more than that in this class. And so we're talking about, and they almost always, we can fit everybody in the class inside a 5 foot by 5 foot area, even though it's not, sometimes it's a little cramped. So if we're talking about 5 feet by 5 feet, then we're talking about 5 times 5, 25 square feet, right? All right, and so if I fit 18 people in here, okay, I've got all these people in here, then I'm going to have 18 people in 25 square feet. And so if we do 18 divided by 25, 18 divided by 25, I get 0.72 people per square foot. I spelled people wrong. People per square foot. Okay, so a little bit more than a square foot per person, I think. All right. So we're going to use this now, this 0.72 people per square feet, and we're going to answer these next two questions. All right, so number 2 says use this value to estimate the size of a crowd that is 10 feet deep on both sides of the street standing along a 1 mile section of a parade route. All right, so here's our street. It goes on for 1 mile. 1 mile this way, 1 mile this way, which maybe you know, maybe you don't know, but that's 5,280 feet. 1 mile is 5,280 feet. And on each side, we have lots of people 10 feet deep. Okay? So we've got all of this is full of people, all of this is full of people. And what we want to know is how many people do we think can fit in there if we're using that ratio from the front page, which would be 0.72 people per square foot. Okay, so I'm going to ask you to figure this out, put your answer. It's going to be in the what you're going to turn in today. All right, put your answer for that. So now we're going to use that same idea, still talking about the 1 mile stretch here with 10 feet deep, but we're going to use a slightly different ratio here. One rule of thumb for estimating crowds is that each person occupies 2.5 square feet. All right, so one person per every 2.5 square feet. So use this rule now to estimate that same crowd. Okay, estimate the same crowd. And I will tell you that this is going to give you fewer people than it did up here. All right, and so I'm going to ask you to put your answer for that one also in today's work. Okay. The last thing is a little bit of a thinking question. We'll skip over 4, but look at number 5. Number 5 says, what other methods could be used to estimate the size of a large crowd? Describe how and why the crowd size estimates applied by event organizers might differ from estimates made by other groups. Okay, we hear this all the time. One group will say, "Oh, there were 50,000 people there," and someone else will say, "No, there was more like 10,000 people there." So what methods might be used, and why do we get such differing opinions here? What do you think? Okay, so that is it for today. Pretty short lesson. Bye bye.